Okay, so till now we have saved all the model object. We have created a sample input. Now we will move on to the creating inference pipeline. So inside the inference pipeline, we will pass all the sample input and model object, and then we will write one logic inside the inference pipeline which will take the raw input data and then it will give the final prediction. Okay, so let's see that. Okay, so inference pipeline is nothing but a simple Python function where we write end to end all the step. So this inference pipeline name is return prediction. Then it will take three parameter: model, scalar object and data. So model is the one that we have saved as a like trained model. Scalar object is used to convert that input raw data into a standard scalar format, and data will be the unseen data that we want to predict. So these are the three input parameters that we need to pass inside the inference function. Now what we will do first, data is in JSON format. Okay, so this data that I have, we are using it as a dictionary. So we need to pass only numbers, not all the like key and value pair. So let's say from this user data, I want to pass only numbers to the model. So if I print user data, I will get all the key and value pair, but I'm interested only for numeric value, not the key value. So in user data, like it's a dictionary. So there are some there are functions like if you print user data dot keys, then it will return a list of all the keys. And if you do the same for values, it will return list of all the values. So this is the values that we need to pass to the scalar object so that it will convert this raw number into a scale format. But if you check the user data values is dict values, it is not properly list data. So on top of that, you need to apply list so that you can typecast the values from this dictionary into a proper format, like in a values in a list format. So same logic I have applied in this part. So whatever the data we will pass inside the return prediction function, it will convert all the data dot values in a list of number format. Okay, then that list will be in a like Python list. We will convert it into an array, because if you compare array and list, so array is much faster than the list object. So that is why whenever if you have this kind of list, you can convert that using np.array function. C, and data type will be integer. And you, if you want, you can type float as well. Or let's say, okay, float, we will pass float only, np.float. So for this particular array, we will pass data type as np.flow, because in few cases we have float number as well. Then this will convert it into a proper array format. And now we will pass this array to scalar.transform function. Now this scalar object is already fitted on the trained data. So we will pass the same scalar object to this inference pipeline function, and it will convert this raw text, numbers into a scale number in and the output will be in W variable. So once you have the scale data, you can just use model.predict function. Now again, model will be the input parameter for this function. So whatever model you have saved, like random forest or decision tree, you can pass that particular object variable inside this model, inside this function, and it will return the prediction on W variable. That W variable is nothing but a scale data. So once you get the result, so model will return the index location like 0, 1, 2 or something like that. So I have created a label dictionary. So 0 indicate insomnia, and 1 indicate none, and 2 indicate sleep apnea. So label will be, let's say, model return 0 value. Then we will use that particular result index location on this label value. So let's say if model returns 0, then from label we will return the value with 0 index, which is insomnia. If model.predict return 1, then we will return value none. And if it is 2, then we will return sleep apnea. in this format. Now here on result, I'm using zero index location. That is because whenever model return the prediction, it will return in a double list format. So let's say there will be one list, and inside that list there will be another list, and inside the list there will be index location for the final answer, 0 or let's say 1 or 2. Now why model written in a double list format? Because whenever the model.predict function returns the prediction, it assumes that the model has multiple input. That is why you will get output in a list format. So this first list is the final output. So model.predict will return the prediction, but from this particular list, we only need to consider the 0th value, which is first list, because as of now we are passing only one input. Let's say if you pass two input at the same time, then model will return in this format. So a list with two lists inside it, and the first first person will have 2, means sleep apnea disorder. Second input that we pass inside the model, that person has no sleep disorder, 1. So in this format model return the prediction, but as of now we are passing only one input, so there is no chance of getting one extra list. So that is why whatever the first list we will get it inside this list, we will take this as a result, and from that index location we will fetch the final label. So this is the inference pipeline. So technically we are just passing the scale data into the model, then we are converting that into the proper list format, and then converting into an array for faster performance. And then once transformation is done, we will return the prediction, and that prediction will be the label. Okay. So let's declare this function. Now to call this function, you can just write return prediction here. The model equal to model is the input parameter for this function, and the model object is again same, because we have already saved the model object in this variable. So model and scalar object have been already loaded using joblib.load function. Okay. Now return prediction will take the model object, scalar model object, and then user data. So user data is the dictionary that we have created by asking questions using this function, ask user function. So once you run this function, you will get multiple questions like what is your gender, age and all, and according to the limitation, a user can enter that particular number. Once the user function is done, if you print user data, you will get one dictionary. Now let's pass the same dictionary, means it's an input to this return prediction function. Now when I execute this function, okay, I got some attribute error, has no attribute float. Okay, so this is because I am passing np.float. Let's run this part now. So we got the output none. Now none is not error or something like that. None is a label. So what it indicates that this particular user does not have any sleep disorder. Okay. Now in this particular part, what we did, we saved the model object, we created the sample input, and then we created inference pipeline. So let's say if a new user enter the data, okay, using this particular function, then we don't need to train the entire model again and do the pre-processing and all. We can just take the raw input and we can pass that particular input data inside this return prediction function, and it will return the final output. So this is the way we need to follow for API development also. So we will get the input. This time in API, we will use a third-party tool or any request library from the Python. So that particular part will return the request to the model. Model will take that input as a input data, and it will pass that to the pre-processing pipeline, like converting into a numbers array format, and then transforming the data, and then finally the model will return the prediction, and that prediction we will send it as a response. So in entire process, return prediction, which is an inference pipeline, is important. So this return prediction function we will use for the model deployment. So this entire project that we have developed inside this notebook will not use the entire notebook. So what we will do on production level or on server level, we will just utilize few lines of code. For example, from this deployment code section, we don't need to use this joblib.dump function. We will only use joblib.load part because dump has already been done. So we will take these 2 lines of code from this Jupyter notebook, and we don't need sample input in API building because we will directly get it from the Postman or any of the third party request Python library. So these 2 lines of code, joblib.load. Next, we don't require this ask user function. This is just for the testing, and this return prediction. That's it. So we will take only this 2 to 3 lines of this 3 object: return prediction, joblib.dump function, load function, and few import statement. And based on only this code, we will create an API and web application for this entire project, so that a user can enter the raw values and get the prediction on the front end or in the API side. So this is the entire process. Now we don't require this entire Jupyter notebook for deployment. So we will just extract that particular code into a PyCharm. So whatever we have done till now, it is in Jupyter notebook. Now when we want to deploy this entire project, we will create a proper folder structure and project structure in PyCharm IDE. We will write entire code in PyCharm for Flask API and web application using different technique like Gradio and Streamlit. That we will see in the next session.